Good morning everyone. So continuing with the videos, let's talk about some interesting facts about squares today. Very important chapter from all the exams perspective. Can I expect that all of you remember the squares from 1 to 25? Of course I can. So let's write down. So 1 square 0 1, 2 square 0 4, 0 9, 16, 25, 36, 49, 64, 81, 100. I assume everyone understands what I am writing, right? All these squares from 1 to 25. So 12 squares, 13, and then we'll move on to 17, 18, that's 20. Good if you can mug up the squares till 50, but at least you have to mug up till 25. That's the prior condition before starting up the aptitude. So that gives you a snapshot about the squares from 1 to 25. Now why I wrote all these squares is the reason is not that you copy it down and you mug it up. No, not at all. The reason is you should be able to understand the pattern in these squares. Now look at the last two digits of all these squares from 1 to 25. You will find very interesting points which I'll just make a note here. Hanji, first interesting point. One hint from my side will be whatever is the last two digits of these squares will always be the last two digits of any square in maths. I repeat, whatever is the last two digits of these 25 squares will always be the last two digits of any square in maths. We can easily prove it by Vedic maths. So those who have watched the Vedic maths video, they know it. Others have to watch my Vedic maths video. Why I am saying this? Believing in that fact that these two last digits will always be the last two digits of all the squares in maths, can I say the last two digits are these? Here the last two digits are these. Have a look at it carefully. Am I able to find a 2 or a 3 or a 7 or a 8 at the last position? No. Very, very important point. A square can never end with 2, 3, 7 or 8. So in other words, the last digit of a square can never be 2, 3, 7 or 8. It can never be. Not for these 25, remember, for every number. Second point. Now just look at the squares, have a close look at all those squares which are ending with 1. Yes, any interesting information? The squares which are ending with 1, their second last digit is always even. So if a square ends with 1, minded students, very, very important point. Remembering these facts, you can answer many questions just by having a look at the options. You need not to even calculate a bit about it. If a square ends with 1, this second last digit will always be even. Can I say the same fact about 4 and the same fact about 9 as well? Yes. If you have a look at the square of 18, which is 324, it is ending with 4 and the second last digit is 2. Similarly for 8 square, it is ending with 4 and the second last digit is 6. Similarly for many other numbers. Same statement goes with 9 also. Third point, if a square ends with 6, The second last digit is always, yes, odd. It is ending with 6, so the second last digit is odd. 14 square, 196. It is ending with 6, 4 square, the second last digit is 1. Similarly, 24 square, the second last digit is 7. It will always happen. Wherever you have a square based question, if an option is ending with all 2, 3, 7 or 8, you can directly eliminate that option. And if an option is ending with 6 and ending second last digit is even, you can again eliminate that as well. Going further, if the question specifies that the last two digits of a square are equal, then they have to be either 00 or 44. No other case exists in mathematics. No other case. If the question says square ends with two same digits, the last two digits of the square are equal, then they have to be either 00 or 45. Last but certainly not the least. If a square ends with 5, the second last digit has to be 2. If a square ends with 5, the second last digit has to be 2. Always. You cannot mix it up with even. If a square ends with 5, the second last digit has to be 2. Now, using these facts, can I answer a question? Very simple question. Suppose if the question says there's a number AB and the square of this number is ACC. Very simple question, where A, B, C are distinct digits. How many combinations satisfy this fact? Now, if you have a look at the question, the first digit is exactly the same. That's the first important point. Second important point, the last two digits of the square are equal. That means they have to be either 44 or 00. Can I eliminate the case of 00? Why? If this is 0, that means the number whose square has been done, the last digit of that number has to be 0. And this cannot be 0. Why? Because B and C are distinct. So that means CC has to be 44. Right? If it has to be 44 and it's a 3-digit square, that means the answer is 12. So 12 square is 144. I know you might be wondering that you know the number is 12 and 12 square is 144, but this is not going to be the real question in the exam. No, the question may use this fact to make a difficult question. So I'm giving you insights how to answer such questions easily. Now there can be a question which says AA square is equal to BBCC. Based upon the same fact and using some knowledge of Vedic mathematics to calculate the squares, you can answer this question as well. So I'll discuss it in the next video, how to answer this question AA square BBCC. One more question for your homework, write it down. TWO square is equal to THREE. Don't worry, I'm not saying 2 square is 3. It is a 3-digit number with TWO representing a unique digit whose square is a 5-digit number whose last two digits are equal, and the first digit of that square matches with the first digit of this given number. You need to tell me the value of all these digits, right? Similarly, for this also you need to tell me the value of A, B and C. They are all representing unique digits. So you have two questions as a homework, which I will be discussing in my next video. Thanks to that. Good night.